Welcome my true Chemilites. Today we are going to still be looking at what alkenes. Now, earlier we talked about the basic infos about alkenes. Now we are going to be looking at what the reactions of alkenes. Now, talking about the reactions of alkenes, there are many types of reaction of alkenes. But first of all, we're going to treat the addition reaction. And inside the addition reaction, we also have kids on that. You get me? So, like in the addition reaction, there are many addition reactions. Okay. So now, first of all, we're going to talk about what the addition reaction before any other one. So, okay. Okay. Now, when alkenes undergo addition reaction, something happens to them. They automatically become alkenes. No matter as far as an addition reaction, no matter the compound, it will always convert them to what? Alkenes. From alkenes to what? Alkenes. Okay, now, the first type of addition reaction we are going to be talking about is what? Catalytic what? Hydrogenation. Okay, in our last class, I hope we remember what hydrogenation means. We said it's the addition of what? Addition of hydrogen molecule, not hydrogen atom. See what we mean? Hydrogen what? Molecule. Okay, now, and we said it's a catalytic hydrogenation. Remember, we talked about this in our former class, and that was when we were talking about what the preparation of alkene. That one, I think that was the first preparation of alkene we talked about. So it's very simple. Now, let's pick our general formula for this reaction. When we have what? Alkene. Remember this dash here means that it can be continued, okay? It can be more than 2 carbon, 4 carbon, 5 carbon alkene. Alright. So moving on. Adding what? Hydrogen molecule. When we add hydrogen molecule, under what? Because it's a catalytic hydrogenation, this hydrogenation must happen in presence of a catalyst. And which catalyst can we use in this addition reaction? We'll use what? We can use what? Platinum. We can also use what? Nickel. And we can also use palladium. Okay? These are the 3 catalysts we can use. Now, after using these 3 catalysts, what will happen to this alkene? It will automatically convert to what? So automatically convert to alkene, which is what? This is what will happen. Okay, now we've gotten our alkene. We already know this, so there's no need of us to start putting examples. You can use what they call it. You can use ethene to get your corresponding what? Alkene. Alright, so now let's move on straight to the next addition reaction that we're going to be talking about. Okay, so now talking about the next addition reaction. Which addition reaction will we talk about next? Let's talk about what? Halogenation. Okay, so this is the second one we're talking about, halogenation. Okay, I believe if we watch the former video, we have the claims and an idea of what halogenation means. Okay, very, very simple. Now, alkenes undergo what? Halogenation. Now, let's write our general formula. Now, what will happen? Halogens, they mostly react as a what? Diatomic molecule. Okay, so now they always react like this. So now when an alkene reacts with what? A halogen, what will happen? It will automatically turn to what? An alkene. As I said earlier, that anytime an alkene undergoes what? Addition reaction. The former one was addition. This guy is also an addition reaction. It will automatically turn to alkene. But this time around, it's not just a normal alkene. It will become a dihalide alkene. You understand? A dihalide compound, which is an alkene. So now let's go. Now there's a way we do this. You don't just come and put it like that. No. In the position of the double bond, the position that is the 2 carbon having the double bond will be where the substituent, like the addition, when we add it, it will be in the same position. You get where the double bond is, because the double bond will break and the diatomic molecule will what? Replace the double bond. Okay, so now these are the groups. Now we have our alkane and our alkane single bond. Okay, we'll now balance our hydrogen. Now after the bond was broken, what will happen? Now this is where the two carbon is. As I said, the diatomic halogen will what? Replace, it will be under the carbon owning the what? Double bond. Okay, now so let's just put it here. This is how it's going to be. Remember, X is representing halogens. It can be bromine, chlorine, or any halogen, fluorine. Okay, so now let's just take an example and let's make sure we understand what has been done here. Okay, now which example do we use? Let's use both 2 in. Okay, both 2 in will be okay. Like I said, it's this thing signifies that what it can be extended or something. You get, but these are it will be. All right. I just put the hydrogen. Normally, I'm not supposed to put the hydrogen because it's a general formula. I'm not supposed to put the hydrogen, but this is how it's going to be. After balancing the whole thing, your halogens will be under where the double bond is. So now let's just use butane as an example. Okay. Okay, from the look of things, we have this compound here to be what? Both 2 what? 2 in. Okay? So now if both 2 in now what? React to what? A halogen. What will happen? Let me write it. Both 2 in. Okay? React with what? A halogen. Which halogen should we use? Let's use chlorine. That will be okay. You can also use bromine when you're writing yours. Okay? So now, when this reaction takes place, what will happen? As I said earlier, the position of the double bond, that is where this halogen will be positioned. Okay? So now, we first, because after the addition, what? The bond will break. After the bond break, we'll now position, remember, the double bond is what? In the second carbon. So now we'll just put our chlorine here. We'll put our chlorine here. The second chlorine will also be here. Then we balance up our hydrogen. It's as simple as that. Okay. And that is it. Now, if we want to name this compound, what will we name it? As I said earlier, remember, when an alkene undergo halogenation, what will happen to it? It will form a what? Dihalide compound. That's what I said earlier. Okay? Write it so that you don't forget. Dihalide compound. Okay? So now, what do we name this guy? We have him to be what? 4 carbons, so both, obviously is both. Then now, let's count where the position of the substituent is. Okay, we have the substituent to be what? Chlorine. And how many substituents do we have? 2 substituents. So the position of the chlorine will come from what? 1, 2, 3. So we have it to be 2, 3. So we can just say this compound here can be written as what? Let me write it up because there's no space down. So we can name this compound as what? 2, 3 what? Dichlorobutane. Okay, this is the name of this compound that will be formed. Remember, the compound is an alkane. As we said, anytime an alkane undergoes addition reaction, it will become what? An alkane. Alright, and it will also form a what? Dihalide compound. Alright, this is what you have to note about this addition reaction. So now let's move forward into the next addition reaction. Alright guys, now looking at the what? The next addition reaction. Now the next addition reaction is what? Addition of what? Hydrogen halides. Okay? Now, this is what we are going to be looking into now. Addition of what? Addition of hydrogen halides. Okay. Now, looking into this, first of all, I want to write the the formula first, the general formula, before what we can look into what it actually means. Okay. Now, This addition of hydrogen halide can also be called what? Markov's addition. This addition reaction can also be called Markov's addition. Now, pay careful attention. Now, let's write what? The general formula for getting this reaction. Okay? So now, as we said, this is a reaction of alkene. Now, when alkenes, what? An alkene react to what? A hydrogen halide. Now, hydrogen halide is written like this. This is an hydrogen halide. Now, when you react to this, what will it give to us? It will give us an alkyl halide or haloalkene. Okay, alkyl halide is also known as haloalkene. Now, the reaction will give us an alkyl halide or hydrogen haloalkene. Sorry. Okay. Now, how do we write it? As we said, the double bond will be removed. It will turn to an alkene. Okay. So now it will be written like this. Now, the position of the double bond, that is where these guys will be placed. As in the former reaction, that is what, which is what, halogenation is the same thing. Okay, but just slight difference. Okay, now, so all right. Now, this is how, that is, this hydrogen here will now come here. You get, this is how the general formula looks like. When an alkene is added to an hydrogen halide, it will become what? A haloalkene or an alkyl halide. Or what? Haloalkene. Now, looking closely, what do we do? Now, I want to explain this thing to you because there is what we call anti-Markov's reaction, and we also have a Markov's reaction. Okay, now in Markov's reaction, which is Markov's addition, also known as addition of hydrogen halides, it is the what? The reaction between what? An alkene and a hydrogen halide to give us what? An haloalkene or an alkyl halide. In the absence of what? A peroxide. Please note this. This is the most important part about it. When you hear Markov's addition, you should know that what? There is an absence of peroxide. But when there is a presence of a peroxide, it is no longer called Markov's addition. It is now called what? Anti-Markov's addition. Okay, now looking at the types of peroxide. Now, so that you can be able to identify them if you see them. Now, examples of peroxide are what? Now, you can look into this. Hydrogen what? Hydrogen peroxide. This one is hydrogen peroxide. We have what? Sodium peroxide. And finally, we have what? Barium peroxide. We have other types of peroxide. Okay, these are just few of them. All right, so now let's take an example and we apply this our general formula to see if it actually works. Okay guys, now looking into an example, we take one example. Let's use let's use botuene. Okay, for using botuene. Okay, this is what? Botuene. Now, if we an alkene, which is what? Botuene, react with what? If you react with a hydrogen halide, what will happen? It will give us an alkyl halide, or also known as what? Haloalkene. Now, looking at this, as we have our example to be botuene. Now, which halogen do we now use? Because we can't represent it with X now. Of course, we have to pick an example. Now we are going to take what? We can use chlorine. We can also use what? Bromine. Now, from this, when these two will react, the double bond will be broken, and what will happen? This alkane will turn to what? An alkane. It's still following that same first rule we said that anytime an alkane undergoes an addition reaction, what will happen? It will become an alkane. Okay, but this time it will become a haloalkane. Okay, so now looking at it, we will first draw our 4 carbon, making it what? Butane. Now, where do we position these guys? As I said earlier, in the position of the what? The double bond. That's the position whereby we are going to place these guys. Being that, what will happen? We'll say we place our halogen here at the what? Second carbon, and what? We balance our hydrogen. Okay. Now, from the look of things, what then do we now call this compound right in front of us? Okay. Normal, we already know is what? Butane. So now, what do? We count and we see where the position our substituent is. The substituent is bromine here and is in the second carbon. So now, we'll now call this guy what? 2-bromo what? Butane. 2-bromo butane. Okay, so this is all you need to know about Volkonikov's addition. It's a very conversant question. They ask it a lot, so please take note of it. Volkonikov's addition is the reaction of what? An alkene and what? A hydrogen halide to give us what? An alkyl halide or what? Haloalkane in the absence of what? A peroxide. Okay, note that. Okay, now let's look at the next what? The next addition reaction. I think that will be the final one for this video, but I will put extra some that too like complex in our advanced video. Okay, all right guys, now from the look of things, the final addition reaction is what? Hydration. Now, the word hydration is not a big word. Okay, now it's very simple. What do we mean? Addition of what? Addition of water. It's simple as that. Addition of water. Okay, now we're talking about alkenes. So definitely, if we react an alkene with water, what is it going to give us? Okay, let's look into that. Now, an alkene react to what? H2O. What is it going to give us? It's obviously going to give us what? An alkanol. Alright? So now, remember the double bond will be broken. Now we are going to add our functional group. Okay? Alright. Now this is our what? Our general formula. Okay, now let's take an example and look what is going to give to us. Now, if we use any alkene, it is going to give us a corresponding alkanol. Now, let's take an example. What is the example I'm going to use? We can use what? Propane. Okay, so if we use propane, okay, 1, 2, propane is what? 3 carbon, obviously. Now, if we balance the hydrogen, okay, that's it. Alright, it's tetrahedrally linked to each other. Okay, so now if we add water, please anyone that I didn't balance, hope you understand. Like the form, most of them are too wide, and like if I start balancing them, I'll start squeezing them up. But after writing the parent carbon, you know balancing of the hydrogen, it's easy work. Okay, if I didn't balance the common, make sure you balance yours in your notes. Okay, now from the look of things, when this propane, we can call this what? Propane. Or what? It can also be called prop 1N, okay? Because of the position of the double bond. Now, if we react to this guy, what is this going to give us? It's going to give us a propanol. Alright? So now we're going to draw it like this. 1, 2, 3. Our 3 carbon. We put our functional group. Okay? After that, what is next? We balance our hydrogen. It's as simple as that. It's just understanding. The reactions of alkenes are simple. Okay? Alright. So we are going to name this guy what? Propanol. Or what? Prop 1 or Okay, now this is the final addition reaction. Alright guys, now still looking into what? Reactions of alkenes. Now we are going to be looking into what? Substitution reaction. Now we are going to talk about what? Halogenation. We talked about halogenation earlier, but this halogenation is different from the other one. A very slight difference. Okay? Now, this type of halogenation we are looking into is what? It's a substitution reaction, also called allylic substitution. Okay, in allylic substitution, also called a halogenation, which is a substitution reaction, what happens? Now, the difference between the other halogenation and this one is that a heat is applied in the reaction, and when this heat is applied, something happens. The halogen displaces a hydrogen atom in the reaction. Okay, so now let's write our general formula. Okay, first of all is an alkene. Okay, we know that. All right, now when an alkene reacts with what? A halogen denoted with what? X. Okay, what will it give to us? As I said earlier, there is what? Addition of heat. That's the difference between the other one and this one, which is a substitution reaction. Now when we add it, what will happen? One halogen displaces one hydrogen atom. Okay, so now we now draw the structure like this. This is how the general formula looks like. Okay, now what do? We have to pick an example to make sure we are doing the right thing. Okay, now let's use a simple one. Ethene. Let's use ethene. Okay, using ethene, we have this. Okay, when ethene reacts with what? A halogen. Let's use what? Chlorine as our halogen. Now, in the presence of what? Don't forget, this is the difference, the major difference, the major difference between the other halogenation and this one. Addition of it to what? Displace one hydrogen atom. Now, we are going to get what? Now, most of you will now be thinking like, why is the chlorine not here? It's actually the same thing. If the chlorine is here, we're also going to name it from this side. If it's here, we're going to name it from this side. Okay, it's the same thing, right? Don't get confused easily. Okay, now from the look of things, we have this compound to be what? Ethene. What are we going to name this guy? We're going to name it what? 1-chloro what? Ethene. Okay, we are going to name it what? 1-chloro Ethene. Alright, still on reactions of alkenes, we can't forget or afford to forget what? Combustion. Now, in the combustion of what? Alkenes, there are points I want you to note about the combustion of alkenes. Okay, now first of all, the product of this combustion is what? Carbon dioxide and what? Water. Alright, so now let's take an example. If ethene C2H4 react with what? Oxygen, combustion will take place to give us what? CO2, carbon dioxide, and what? Water. Now, but from the look of things, this equation is yet to be balanced. So now let's balance this equation. Okay, yes, so okay, this guy, and finally now we'll balance this equation. This is the combustion of alkenes. Now there is point I want you to know. There are difference between the combustion of alkenes and alkenes. As we said, alkenes means what? Little affinity. That is why they are called paraffins. Now, alkenes, the they undergo combustion, but their combustion is not like alkenes. It's a little bit lower, and but in alkenes, the combustion is more luminous, it's more bright, and what sooty. Okay, just notice that's the difference. That is, this guy is more luminous and sooty than alkenes, the combustion of alkenes. All right. So on that note, now what do we do? Let's look at the first member of the alkenes family. I think we've touched a lot of places, but I'm going to look deeper into alkenes in the advanced video. Don't forget. Alright guys, finally we are going to be looking at the first member of the alkenes. Now there are sharp points I want you to note about the ethene as the first member of the alkenes family. Now, first of all, I want you to know that this compound here is what? Neutral to litmus. Secondly, I want you to know that it is colorless. Now, also, what else do we have to note about ethene? Ethene is what? It has a sweet smell. Okay? These are characteristics of what? Ethene. Now, looking at ethene, it is also used to hasten the ripening of fruit. Okay? So we can also write it here. Now, this thing is actually a question, a jam question. It's repeated a lot, so please note it. It's not ethine, E-N-E. Ethine has its own uses. So I'm going to talk about it when we are talking about the alkynes. Okay, this is ethine, because sometimes confuse people. They don't know the difference. The one which is used in the ripening of fruit and the one which is used in miner's lab. Okay, this one is used in the ripening of fruit. Now, the next thing I want you to note about this ethene is that it is used in making what? Polyethylene and what? PVC, also called what? Polyvinyl chloride. Okay, let's write it. Used in the production of polyethylene and what? There's no space. I wanted to write the full name, polyvinyl chloride. Polyvinyl chloride, but I'll just write also known as PVC. Okay. Now, another uses of ethene. When ethene reacts with oxygen, in the presence of a silver catalyst, it will give us what? Epoxy ethene. Note it. When this guy ethene reacts with what? Oxygen. If it reacts with oxygen normally, it's not going to give you epoxy ethene. But in the presence, it reacts oxygen in the presence of what? A silver catalyst. It will yield what? Epoxy ethene. Take note of that, epoxy ethene. Alright, I think these are important points you should have to note about the first member of the alkenes family, which we call ethene. Now we are going to talk more about the polymerization of alkenes when we are looking into the polymer chemistry, because alkenes are used in the production of rubber. When alkenes undergo polymerization, they become plastics. Okay, so we're going to talk about that in polymer chemistry. We'll get to that. Okay, so now these are the points I want you to note about ethene. Okay, this is the end of this video. We're going to be looking further and advanced into alkenes in the next video I'm going to drop. Okay, make sure you watch that video. Thank you for watching my True Chemilites. Make sure you check your sweet drops. Okay.
Rub this on the face. On the face of the person that you want to make mad. On the face of the person that you want to make mad.
Wala nang kuna rin. Baba, bless you, ding dong bell.